Hey guys, today's Tuesday, May 5th, and we are going to be working on Goal 9, approximating the area under a curve using rectangles. Think back to when we first started this chapter. I told you that one of the most common questions in calculus is approximating area under a curve. So eventually we will be able to have a problem like this, and they will say approximate the area under the curve of g of x between the interval 2 to 8. So what that means is we need to figure out the area of this shape here. This is a shape that we do not know an area formula for. However, we are going to learn today how to break this up into rectangles, such as something like this. And then we will find the area of each rectangle, add them up for an approximate area of the curve. Let me show you some examples. This problem says approximate the area between the curve f of x and the x-axis on the interval 0 to 12. The first step is to graph f of x and make sure you adjust your window so you can see the entire curve on your interval. Make sure you sketch this on your paper. So when you first graph this function on your calculator, which you should go ahead and do now, you'll probably see just what you see here in this first screenshot. This is what you'll see on a standard window. So I obviously cannot see the entire curve. I need to change the window. So what I did was I made my x min -1 and x max 15 because I know I'm looking at the intervals 0 to 12. For my y min and max, I had to adjust this a couple of times, but I know that I'm going between the x-axis and the curve, so I know that my x min could just be -1 or -2, and my y max, this was the one I had to adjust a few times until I got all the way to the top of the curve, but I just went with 40 for my y max. Now that I can see the entire curve, now I can sketch this on my paper. And what this question is asking us, again, just to reiterate, notice that we do have zeros at 0 and 12, which is nice because then that fits perfectly on the interval. But it's basically asking us to find the area of this shape here. This is not a shape that we have an area formula for. So we will need to use approximation using rectangles. On Thursday, you'll learn how to actually find that exact area, but we don't know how to do that yet. Once you have this sketched on your paper, what you want to do is divide up the interval on the x-axis. So we know the interval is 0 to 12 into the number of intervals required. Note that the length or the width of each interval would be equal to the maximum. So in this case, it's going to be 12 minus the minimum of the interval divided by the number of rectangles that they want you to use. For this example, we're going to do 3 different sizes of rectangles. We're going to use 4 rectangles, 6 rectangles, and then 12 rectangles. So let's go over this. If we want to use 4 rectangles, we need to figure out how wide is each rectangle going to be. So we know that we're looking at this interval from 0 to 12. So altogether, that would be 12 units. I found that by taking 12 minus 0. And what I want to do is divide this up into 4 equal rectangles. So I did 12 minus 0, that's 12, divided by 4. So I get that each rectangle should have a width of 3 units. So what I did was I started at my leftmost point, and I counted 3 units on the x-axis. And I just have to keep doing this until I get to the end point, and you should end up with 4 rectangles, or 4 different spaces on your x-axis. Let's go ahead and divide up our x-axis for 6 and 12 rectangles as well. So for 6 rectangles, we're taking the 12 units and dividing it into 6 equal rectangles or equal spaces. So that gives us that each rectangle should have a width of 2 units. So starting at 0, I'm going to count 2 units So count by twos all the way to the end point of the interval, which is at 12. And that should give me 6 rectangles. You might just want to double check. Yes, that gives me 6 spaces, so I know I will be able to fit 6 rectangles in here, with each having a width of 2. Now let's check for 12 rectangles. This one, you should be able to figure it out pretty easily. If you have 12 units and you want to fit 12 rectangles, each rectangle has to be 1 unit wide. So I'll divide this up into 1 unit segments, and you can double check this if you want. Obviously for this one, it does make 12 different sections. Once you have your x-axis split up, the next step is to find the height of each rectangle and sketch it out. So you want to use the table on your calculator to find the heights. Most commonly, you're going to use the left endpoints, right endpoints, or midpoints to find the heights for each rectangle. But you don't have to. You could have used any point inside the interval. So for example, if you're using 4 rectangles, if you're using the left endpoint, you would use 0 for the first rectangle, since that is the left endpoint of the first segment. You would use 3 for the second, that's the left endpoint of the second, 6 for the third, 9 for the fourth. Those are the left endpoints. However, you could really choose any point between 0 and 3 to find the height of your first rectangle. We're going to do all 3, left endpoints, right endpoints, and midpoints, just so that you have an example of each. Once you find the height of each rectangle and you sketch it, the last step is to find the area of each rectangle. Once you have the area of all 4, 6, or 12 rectangles, you can add them all up for the total approximate area. Note, area of a rectangle, hopefully you guys already know this, but it's equal to the width times the height. Let's do an example. So first we're going to use right endpoints, and we're going to use 4 rectangles. So what we need to do is, we already know that we split this up into 4 rectangles, and each one has a width of 3. So what I like to do is go ahead and write this out. Area 1 for the first rectangle, area 2, area 3, and area 4. Since there are 4 rectangles. Obviously, if you have more, you'd have to keep going. Each rectangle, remember the area of the rectangle is equal to the width times the height. So, the width of each of these rectangles is 3 units, just like we said earlier on when we calculated the width up here. So if we're doing 4 rectangles, the width is 3 units. So we know that to find the area of each of these, it's going to be 3 times the height. Now we need to figure out the height for each rectangle. This one said we are going to use the right endpoints to find the heights. So what we're going to do is look at the first segment. The right endpoint of this segment is 3. So to find the height for this rectangle, what you're going to do is you are going to use the height at 3, or the function value at 3. So the height is the function value of 3. So if you plug this into your calculator, you should get 27. So we can sketch this out. Should be approximately here. So there's our first rectangle. Oops. Oh my gosh. Alright, for the second rectangle, I can't get that unhighlighted. I'm just going to have to use a different color. For the second rectangle, we're looking at this next segment. The next segment goes from 3 to 6. The right endpoint of this segment is at 6. So we know to find the area of the second rectangle, we're going to use whatever this point is that we get at 6. And we're going to draw our rectangle in. There's our second rectangle. So we have the first rectangle, the second rectangle. The height of this rectangle is going to be equal to f of 6. For our third segment, we are looking at the section between 6 and 9. The right endpoint between 6 and 9 is 9, obviously. So we need to figure out how high is that going to go. That goes up to about, let's see, maybe around here. So we'll draw our rectangle in. There's our third rectangle. The fourth rectangle, we are looking at this segment from 9 to 12. The right endpoint of this rectangle is, of this segment is 12. The height of this rectangle, since when you plug in 12, this is a 0, the height is just 0. So this is actually not really a rectangle at all. It's kind of just a segment. So now we're going to go through each of these. So the first one, for width times height, let me give us some more space. We have 3 times f of 3, because the width is 3, the height we can find by doing f of 3. F of 3, I would plug this into your table. When you plug in 3 to your table, you should get 27. 3 times 27 is equal to 81. We're going to do the same thing for the other 3 rectangles. So for our second rectangle, the width, again, we already said the width of all of them is 3. The height of this rectangle is going to be the same as plugging 6 into the equation. So I would just plug in 6 to the equation on your table, and you get 36. 3 times 36 is equal to 108. The third rectangle has a width of 3, again, because they all have a width of 3. And the height is going to be the same as plugging in 9 to the function. So we're going to plug in 9. I would do this on your table. When you plug 9 into your table, you should get 27. 3 times 27 is equal to 81. Last but not least, our last rectangle here, the fourth rectangle, remember we said it has a height of 0. And if you double checked, plugging in 12 to your table, you should get 0. So the area of that fourth rectangle is 0. Now to find our approximation, you're going to add all these up. So you have 81 plus 108 plus 81 plus 0. You're adding up the area of all 4 of your rectangles. When you do that, you should get 270. And we can go ahead and say this is units squared. So the approximate area that we got under this curve is 270 units squared. Now let's look at the same problem, except now we're going to use 6 rectangles. I went ahead and already drew the 6 rectangles in using the right endpoints. So the right endpoints of each segment are shown here, and I drew the rectangle in. So as you can see, there are 6 rectangles here, and the heights I highlighted for each rectangle. For 6 rectangles, each rectangle has a width of 2 units. So I went ahead and wrote that out first. So I did area 1 equals 2 times f of 2, since 2 is the right endpoint of the first segment. For the second segment, the right endpoint is 4, so that's how I knew to use f of 4 for the height. For the third rectangle, 6 is the right endpoint, so I knew to use f of 6 to find the height, and so on. Once I do that for all 6 rectangles and multiply each of the heights by the width, all I have to do is add up all 6 areas to get the total area approximation. So this one compared to the last one, which one does it look like is approximating the area even better? Does it look like 4 rectangles is closer to the area under the curve? Or does it look like 6 rectangles is closer to the area under the curve? So far it looks like 6 because we're including a little bit extra here, but we're also missing a little bit. Let's do pink. We're also missing a little bit over here. So what do you think? Do those even out, the spaces that we're missing with the spaces that are extra? To me, I would say probably not. It looks like we're missing a little bit more than what we have extra, but you can see what you think on that one. Now let's look at dividing our sections, our x-axis, into 12 rectangles. So here you can see I already divided it out into 12 rectangles, and I'm using the right endpoint to find the height of each rectangle. So for example, for the first rectangle, I used the right endpoint, which is 1, to find the height. The second section was from 1 to 2, and I wanted to use the right endpoint to find the height, so I went up from 2, and so on. The width of each of these rectangles is 1, and the height I can find by using the right endpoint and plugging it into the function. Once I do that, I get all 12 of my areas, and then you just add them up to find the total for all 12 rectangles. So this one answer is a little bit larger than the last answer. Let's inspect the graphs. So this time, we have a little bit extra over here again. Just a tiny bit. But we also are still missing a tiny bit over here under the curve. What do you think? Does it even out? No? Hopefully you said no. It doesn't even out perfectly. It's not a perfect area under the curve, but we're getting even closer. So notice that as you have more and more rectangles, the area is getting better and better. So far our best guess for the area is around 286 units squared. The next thing we're going to do is look at this, and we're still going to split it into 4, 6, and 12 rectangles, but this time, instead of using right endpoints to find the heights, this time we are going to use the left endpoints to find the heights. And we'll see which one do you think is better. So for the left endpoints, we already have our x-axis split up from before. The first segment goes from 0 to 3. The left endpoint of that segment is 0. So I'm going to use 0 to find the height. So for the first rectangle, I know that the width is 3, and the height I'm going to find by using the left endpoint, or f of 0. F of 0 is just 0. So notice that this rectangle is not really a rectangle at all. The area of this first section is 0. For my second section, I'm going from 3 to 6. The left endpoint is 3. So for the second section, the width is still 3, and I'm going to plug in 3 to find the height. F of 3 is 27. So if I want to draw this on here, it goes to about here. Here's my second rectangle. 3 times 27 gives me 81 for my second rectangle. Now let's look at the third section. The third section goes from 6 to 9. The width is obviously still 3. The height I'm going to find by using the left endpoint. Since 6 is the left, I'll use 6 to find the height. There's my third triangle. So since I use 6 to find the height, I know that's f of 6. F of 6 is equal to 36. 3 times 36 is 108. So 108, that's the area of the third rectangle. Our fourth space is between 9 and 12. We want to fit a rectangle in here in this space. Remember, we're using left endpoints. So the left of that would be 9. Oops. And it goes up to about here on our graph. There's our fourth rectangle. To find the area of the fourth rectangle, the width is 3. The height, since we're using the left endpoint, is f of 9. F of 9 is equal to 27. 27 times 3, again, is 81. To find the total area for the approximation, I add up my 4 areas for my 4 rectangles. So I have 0 plus 81 plus 108 plus 81. That gives me a total of 270 units squared. So notice that for using 4 rectangles, whether we use the left endpoints or the right endpoints, it gave us the same answer. This will not always happen. It just happened on this function since it was actually like perfectly symmetrical on this interval. Next, let's look at 6 rectangles again. I already did this work for us, but this time we're using the right endpoint. So on the interval from 0 to 2, the right endpoint would be 2. Oh, sorry, we're using left endpoints this time. So the left endpoint would be 0. So I get the height of the first by doing f of 0. F of 0 is 0, so this really isn't even a rectangle at all, just like the first practice problem. For the second interval, within this interval, I have to fit a rectangle between 2 and 4. Since I'm using the left end to find the height, I'm using f of 2 for the height. I did the same thing for all 6 rectangles and then added them all up together to find the total area. Similarly, for 12 rectangles, I'm using the left endpoints to find the height. The first rectangle isn't really a rectangle at all. The second rectangle, I use the height found by plugging 1 into the function. So that's f of 1. The third section is from 2 to 3. The left end finds the height, so that would be found by plugging 2 into the function. So that's why I have f of 2 for the height, and so on. Once I find all 12 areas of all 12 rectangles, I can add them all up to get the answer for the approximate area. Next, let's use midpoints. So this one is not as common, but it still sometimes does ask you to use midpoints. So let's think about the midpoints here. Our first section goes from 0 to 3. The midpoint of 0 to 3, if you need a quick refresher, midpoint is kind of like average. It's equal to x plus x divided by 2. So 3 plus 0 divided by 2, the average of 0 and 3 is 1.5. So I'm going to use 1.5 to find the height of this rectangle. So I'm just going to go up and guess. It looks like it's about there. So that's my first rectangle. So area of the first rectangle, the width is 3. The height I found by plugging 1.5 into my function. So that's f of 1.5. For my second rectangle, I'm looking at this section from 3 to 6. The midpoint between 3 and 6 is 4.5. So I'm going to estimate. I'll just go up from 4.5. It looks like it's about here. It doesn't have to be perfect. There's my second rectangle. So to find the area of that second rectangle, the width is 3. The height, I'm using the midpoint, so I'm going to do f of 4.5. The third rectangle is on this space from 6 to 9. The midpoint between 6 and 9 is 7.5. So I'll just estimate the height at 7.5. Looks like it's about right here. And I'll draw this rectangle in. There's my third rectangle. To find the height of that rectangle, I know the width is 3. Sorry, the area. To find the area, the width is 3. The height I'll get by plugging in 7.5. And finally, for my fourth rectangle, I am trying to place a rectangle between this space, between 9 and 12. The midpoint between 9 and 12 would be 10.5. So I'll just estimate. That looks like it goes to about here. So let's draw that rectangle in. There's my fourth rectangle. To find the area of the fourth rectangle, the width is still 3. The height is whatever I get when I plug in 10.5 to my equation. So let's go ahead and go through this. So I have 3 times f of 1.5. So again, to find these function values, I highly recommend using your table. F of 1.5 is equal to 15.75. 3 times 15.75 is equal to 47.25. So that's the area of the first rectangle. The second rectangle, I need to find the height first by plugging in 4.5. Gives me 33.75. And when I multiply that by 3, the area of the second rectangle is 101.25. The third rectangle, I need to plug in 7.5 to find the height. Again, that gives me 33.75. So I multiply it. The area of my third rectangle is the same as the area of my second rectangle. Last but not least, for my fourth rectangle, I need to plug in 10.5 for the height. The height is 15.75, which gives me an area of 47.25. Once you have all 4 areas for all 4 rectangles, you add them up to get your total area. So add these all. You should get 297 units squared. I did the same thing for 6 and 12 rectangles just so you can see. For 6 rectangles, I got an answer of 292. units squared. For 12 rectangles, I got 289 units squared. I would say that out of all 9 of these examples, this one probably, to me, looks like it's the closest to the actual area, but you can think about that and decide that for yourself. Which one do you think came the closest to the actual area under the curve? Was it using midpoints? Was it using left endpoints? Or was it using right endpoints? And how many rectangles gives you the best area approximation? Your homework for tonight is on page 781. You have numbers 4 and 10. On number 10, they asked you to use both left endpoints and right endpoints. So you're first going to do it with left endpoints, then you're going to do the exact same problem using the right endpoints. And then what they ask you to do is take the average of these two answers. So remember, average is equal to adding the two numbers. So you could do like x plus y divided by 2. So whatever you get for the first answer plus the second answer and divide it by 2. Your reflection question is number 43 in the book. Make sure you fully explain that answer in your own words. Thanks, guys. Have a great day. Bye.